Hey, I wanted to share something with you, and I thought I'd put it into a little video because it really needs to be seen, to be appreciated. And here it is. This is what I want to show you. You can see by looking at it, I hope, that it's actually a spiral shape. See, as I follow up, this goes around, goes behind it. It's a spiral. And you may think, well, this guy took spheres and some glue and used his artistic ability, whatever he had, to make this by putting these spheres together, and so that it looked like a spiral. In other words, I tried to use my artistic eye to pull this off. But you would be wrong because the way that this was put together was following some simple rules of geometry and mechanics, which automatically turned this into this spiral as I glued it together. And the great thing is I didn't expect it. I didn't see this coming, but I think there's possibly some wonderful significance to it. So here's how this happened. I had studied Nassim Harameyn's course on unified physics. Anybody can go through that course for free on his website. And during that course, he spends a good bit of time describing the structure of space, the geometry of space, and he had learned about this originally from Buckminster Fuller, who had worked on it before, and he himself had made models of this space and using spheres, like I did with this spiral here. But the actual structure of space is something that Fuller called the vector equilibrium, and it looks like this. Maybe a better way to visualize it first off is to see this picture. It's also called the cube octahedron, and each one of these little points right here represents the middle of one of these spheres, the center point. But it's actually built upon spheres, not a thing with sharp corners, object like I show you in that picture. That just shows you the configuration of it a little easier. So I've been playing with these. I got curious because if you look at this, the structure of it is a combination of fours together and threes. It's all it is. Now, most people understand that threes put together makes a very stable structure. However, four put together is not so stable. It's not locked in like the three is. And just to demonstrate that, if I take a rectangle or a square, you see how these are free to move. So the most stable formation is the triangle. It got me thinking, I wonder what would happen if I started playing around with these things and putting them together, but I wanted to see what would happen if I limited my gluing together to just the threes. So I'm only using the most stable structure, geometry. So here's what happened when I tried to do that. Sphere number one, let's bring another one in, and it turns out in the structure space, these spheres, they are attracted to each other. They want to, say, stick together, you could say. Pop. So I have one, bring in another one, we have this, and then if we bring in another one, we're going to get this. Is the only way it can look is like this. And then if we start bringing in more spheres to connect them, first of all, we get this, which is basically the tetrahedron, the most stable three-dimensional form. And then if we continue on, let's say I try to continue adding, and the way I do it is I try to add it just in one direction to make it go out, but limit it to these threes, no fours, okay? Well, when I did that, after a little while, it became clear that something was happening. And after I did quite a few, it was quite obvious that I was making a spiral. Spiral, does that remind you of something? How about a vortex? So to make it more interesting, in the class on unified physics with Nassim Haramein, he a couple times gives an analogy. It's a fun little analogy of, think of a bathtub, rubber ducky in the bathtub, and somebody pulls the drain in the bathtub and the water begins to drain. And then what do you get? You get a whirlpool, right? Everybody knows the whirlpool in the bathtub. His point in this analogy was that what's happening is you're having a density differential. So there's one density in the bathtub water, and then in the drain, the density is much less, thus the water is draining out. It's a density differential. And in this density differential is what causes the vortex, the whirlpool. Now, the thing about a density differential that everybody sort of understands, I think, naturally, is that it always wants to even out. The higher density wants to even out with the lower density so that it's no longer a difference in density. And this is how you can get a directional flow. Think of in weather, for instance, high pressure air and low pressure air. What do you get? Wind. And the wind goes in a certain direction, right? Or take an electrical circuit. If you've got high density of electrons on one end and low density on the other end, you have made a differential, and you have what they call it potential. I guess you'd be voltage. So there can be a flow in a direction from the high density to the low density. So I can apply that same density differential idea to my little experiment with my spheres here. Okay, so here's my baseline of spheres, let's say, and it's all surrounded by other spheres somewhere. And let's say there's a density differential. Let's say higher density is up here above. Let's say lower density is down here. So that being the case, from what I said previously, we understand that it's going to tend to set up a flow, a direction of movement from the higher density to the lower density. So we have a direction. And now picture these spheres coming to this baseline here, and it's coming from a certain direction. It's going to link up on here, starting with that. And then the next one's going to come, and it's going to want to link up to the easiest place for it to connect based on the direction of its approach. And this is what I ended up with. This is my whirlpool in the bathtub, you might say, and it might have other significance too. Okay, so I wrote this down based on everything I learned from Nassim Haramein's unified physics, and also from Marshall Lefferts' book Cosmometry. Those two guys work together a lot. And what I wrote was that every realization of matter or energy from the vacuum, space, into the physical realm comes through a vortex of, yes. In conclusion, I just wanted to say I don't really have the background to try to work putting together an actual 0 point energy device. So I've just been studying in this theoretical realm of what can be involved in making this happen, and just hoping that something will make a connection between the theoretical and the practical at some point. I have no idea if this would be helpful in any way, practically speaking. If nothing else, it's an interesting thing to look at, and at best, maybe it'll help put something together for somebody that's working on the nuts and bolts of putting together a 0 point energy device.